Now we've looked at series circuit, let's take a look at parallel circuits. A parallel circuit is one where we have a source of potential difference, so a battery or a cell, but rather than one loop, we've got more than one loop. So in this case, we will have 3 loops, one at the top, one going through the bulb in the middle, and one going through the bulb at the bottom. Let's take a look at the difference then between a parallel circuit and a series circuit. So these are 2 different circuits side by side. Here's our series one with 1 loop, and here's our parallel one with more than 1 loop. The first difference is that in a parallel circuit, the potential difference across each component is the same. So what do we mean by this? If we remind ourselves of a series circuit, let's say it starts at 12 volts, assuming these resistors are both the same, this one would have 6 and that one would have 6. In a parallel circuit, if we have 12 volts here, each loop has 12 volts because each one is directly connected to the power source. So we can see the blue line is connected to the power supply and the green line is also connected directly to the power supply. If there were bulbs, these ones would be dimmer because you've only got half the potential difference, you've got a share of it. If these were bulbs, these would both be nice and bright because they're directly connected to the power source. So because they're directly connected and there's 12 volts, the battery works harder. So this one would last longer than this one. The one in parallel transfers more energy per second to the components compared to this one because they're directly connected. The rules following the current is also different with a parallel circuit compared to a series one. The total current through the whole circuit is the sum of the currents through the separate components. So let's take a look at what that means. On a series circuit, the current was the same all the way around. However, in a parallel circuit, what happens is the current flows and it gets to this point just here, and we call it a junction. Some of the current will then flow through this resistor, and some of the current will then flow through the other resistor. So the total current coming out of the power source then separates through each component in the circuit at a junction. As a reminder, the potential difference stays the same, but the current splits. And it doesn't always split evenly, it all depends on how much of the resistance there is. So let's say we've got 3 amps coming out of the power source, and if they are the same resistor, 1.5 will go this way, and the other half will then flow the other way. So if the resistances were different, and now let's say the current flowing out of the power source is 4 amps, 4 amps would flow here, and let's say 1 amp goes this way because it's got a higher resistor. That means 3 amps would go the other way because it's got a lower resistance. So in this case, the 4 that we started with then is 1 plus 3, 1 amp, and then the other 3 amps splits at the junction and goes the other way. Likewise, when it meets at the other end, the 3 amps then joins with the 1 amp, so all the way along here would also then be 4 amps because they join back at this junction. They split at this one and join back at that one. And the final bit you need to be aware of is the total resistance of 2 resistors is always less than the resistance of the smallest individual resistor. So when they were in series next to each other in one loop, we always added them up, so they got bigger. But you need to be aware when they're in parallel, the resistance gets less.